Hello, let's continue our Sudoku adventure with Zeroed In by GDC. So we have normal 0 to 5 Sudoku rules, so that means in every row, every column, in every box, we are placing the digits 0 to 5. We also have these blue lines in the grid. These blue lines are region sum lines. So the sum of the digits on the line is the same within each box, but if the line re-enters a box, it starts a new sum. So let's use this line as an example. So first we just go along the line and say, okay, these two are in the same box, so let's color those green. Now we're transitioning into a new box, so let's make that purple. And then we transition into a new box where it's re-entering this box, but we consider it a new box because it's re-entering. Let's make those yellow. Actually, I think yellow looks similar to green, but anyway, let's make it blue. I don't think yellow looks similar to green because I'm not colorblind, but I've heard that colorblind people have trouble distinguishing the yellow and green, so I try to avoid that. Anyway, do let me know. I know there's different forms and intensities of colorblindness, but anyway. My point here is that we have now separated them by color, right? The green cells sum to the same as the blue cells, which is whatever digits filled in the purple cells. Do you remember we have 0 in this puzzle? All right. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. I don't know which one to think about first, but let's think about this. So what is the minimum these 5 cells could add up to? Well, it's going to be 10, right? Because we can do 0 through 4. That would add to 10. That's the minimum. We would divide that by 2 to get this value. That would be 5. And 5 is our biggest value. So we get our first digit. That's a 5. Now, where does 5 go in this box? Well, actually, it could go on here with a 0, 5. That's interesting. But if we did that, we couldn't add to 5 here. Right. We need to add to 5 and 3. I was like, how does that work with the math? Anyway, 5 does end up here because we need to add up to 5 and 3 here. And the only way we're doing that is using a 0. So the 0 is down here, which means the 0 is not up here, which means this adds to 5. Without the 0, which means the 5 in this box has to go here. Now this is the same. We need a 0 somewhere in here. Now how are we adding to 5? It's going to be either 0, 1, 4 or 0, 2, 3. So we don't really know how the rest of the digits are laid out. Same thing here, but it does put the 5 here. Okay, so now 5 in this box is one of these two. Now, okay, we can't do 5, 0 here because this would also be a 5, and that's very bad. So the 5 goes here. In fact, this can't be a 5 at all. So it probably ends up being a 4. Let's see. These digits can add to 6. Actually, it could be a 3. Because these digits can add to 6. 0, 1, 2, 3. Adds to 6. So this is a 3 or a 4. And that makes this cell, let's see, if this was a 3, obviously the 4 has to end up here. If this was a 4, I could do 0, 4 over here with 1, 3. I think I have to because I can't do 2, 2. So the 2 would end up there, actually, in the case of 4. That's pretty interesting. Zero math is weird. Here, these 3 cells. No, sorry, these 2 cells. Okay, these 2 are the same digit as each other, first of all. These are the same digit as each other, and that goes on to this line. Now, these sum to that. Now, on this line, we can't put a 5. We already know these can be 5. With 0, it's tough. We know these aren't green. Green could go down here, but this could be green if this was 0. I'm going to think about this further. Okay, so this is going to add to 5, which means these add to 5 as well. Yeah, because a whole row adds to 15. So these are going to add to 5. So we're going to have, 1, 4, 2, 3, which I know doesn't mean much, but we do have a virtual 3, 4 pair here, right? Because we need to include a 3 or 4 here in order to add to 5. And this is the other 3, 4 in the box. So these can't be 3, 4. These are from 1, 2, not 3, 4, not 5, but they could be 0. In fact, 0 does end up here, of course. This is from 1, 2, 3, 4. Now, it can't be a 1. Yeah, it can't be 1 because these are different than green, right? If they could be the same as green, then they could be 1. In fact, they can't be 2 either. Because even if we use a 0 here, we'd have to repeat green, right? So we can't use a 0 here or we'd be repeating green. So 0 does not end up here. 0 is in one of these two. And so these are from 1, 2, 3 only, which means they add to 3 or 4. And they must use the 1. Okay, so green is not 2. Green is 3 or 4. Makes me think 0 goes on here with green. But no, this can't be green. Let's call this purple. This is the other 3, 4. And so green plus what is purple? Well, it's going to be green plus 1. So green is 3. This is a 1, 2 pair. This is a 4. And this is a 1, 3 pair. Okay, I figured it out. That was neat. That felt satisfying. 1, 3 pair also removes the 1. So that's a 2. This is a 0, 1 pair. So this is 2, 3. And this is 0, 1, 4. Okay. Starting to clean up. What's next? These add to 3. We could be 3, 0, or we could be a 1, 2 pair. Oh, this 1, 2 pair does give us the 0 and the 1. I should scan better. We also know that this is a 4, so that's a 2. These are 4 and 6, and we know the wait. No, this sorry, there's no 6. They're 4 and 0, and we know the order. That's 0, that's 4. Also, this has to add the 4. I was like, wait a minute. I don't think 4 plus 6 is 4. Anyway, we don't need the purple either. That's not a 0. We found where the 0 goes here. So this adds to 5 and this adds to 5. Now I can already tell you this isn't going to be 2, 3 because then we would have a unique rectangle here. But we'll prove that without uniqueness. In fact, this is 1 or 3. So if this was 1, this would have to be 4. If this was 3, this would have to be 2. We already know which one it is, but I'm not gonna use that. Let's just put 1, 2, 3, 4 there in case it helps. Over here, this is a pair. This is 0, 5. I have to remember it's 0, not 6. Do we have anything else of note to do here? The 4 ends up here. The 3 ends up down here somewhere. Okay. What can I do? Oh, this column needs a 5. So the 5 goes here. That's a 4. Sorry, there was some commotion outside. 0, 5. That's not 0. That's not 4. Okay, we get the 2 and the 3 here, which I said would happen. That's a 1, 4 pair. So that's 3 and 1. Do it in the corner. Nice. I feel like we're almost done here. 1, 4 pair tells us this isn't 1. If that's not a 1, then this can't be a 2. So this ends up being 1 and 2. Yeah, 0 got off of that. Okay, so that's 1 and 2. That's 3 and 2. That's 4 and 1. We get the 0, 4 and 1. And then we need a 0 and we need a 3. And we're done. All right. Well, that was a cool puzzle, GDC. I really liked the logic in that one, especially finding this 3, 4 pair and then finding that it had to go on here, forcing it to be a 3. That was neat. Yeah. And 0 definitely, I'm just not used to 0, but 0 definitely adds complication to these sum constraints, which is nice. And I think unlike killer cages, you can't just add 1 to everything because you'd have to like add 2 to the ones that are the sum of 2. But then what do you do to this one, right? I don't think there's a good way to think about that if you try to get rid of the 0. So that's neat. And of course, if you enjoyed this, why don't leave a like, subscribe, and a kind comment below.